Okay, here's the TEKS test review. First question, let's go ahead and get right into it. Linda works as a lifeguard for $15 an hour. She also babysits for $10 an hour. Linda needs to earn at least $120 per week. You can already tell this is the equation right here for that. But does not want to work any more than 30 hours a week. So the max she's going to work is 30 hours per week. Graph the systems of inequalities below to represent L, the number of hours working as a lifeguard, and B, the number of hours babysitting. So that's that first one. She earns at least $120 per week, $15 lifeguarding, $10 an hour babysitting, and when you add those two up, it's always bigger than 120 or the same. But she doesn't work more than 30 hours a week. That's why my hours lifeguarding and my hours babysitting are less than 30. Then we have these other two right here. L is greater than or equal to 0. L is lifeguarding. That just simply means that it's positive. We can't have a negative numbers of lifeguarding. Just like with a B, we can't have negative numbers babysitting. We can't drop down here. That just keeps us in the first quadrant. Now it says circle all the ordered pairs L and B that are in the solution set. L is like the X, B is like the Y, just like it's X and Y, just like that. So what we need to do is graph these two lines. To graph those lines, we're going to solve them for Y. That's why I designated X and Y. And again, Y here, Y-axis is the B, X-axis is the L. So let's solve the top one for Y. We have 15X plus 10Y is greater than or equal to 120. We want to get the Y by itself to graph it. So we're going to get rid of the X. To get rid of the X, we're going to subtract it from both sides. That's going to go to 0. And we're left with 10Y is greater than or equal to negative 15X plus 120. Then I need to get rid of 10. Going to divide by 10, divide by 10, divide by 10. When I divide, that gets me my Y by itself. If I would have divided by a negative number, I would have to change the sign. But I did not divide by a negative, so I do not change the sign. Negative 15 divided by 10 will be negative 3 over 2. If I put that in the calculator, alpha y equals negative 15 divided by 10, 3 over 2. And then I have 120 divided by 10. I can simply leave that as plus 12. Let's graph that. I'm going to start my y-intercept of 12. Y-intercept of 12, just like that. And then my slope, my rise and the run. Down 3, right 2. Each of these lines are 2. 2, 4, 6, 8, 10, 12, 14, 16. So if I'm going to go 3 down, it's going to be halfway between the lines. And then I'm going to go 2 over. That's 2 right here. 2, 6. So each of these lines goes by 2. So that's 3 down, 2 over. Then I'm going to go 3 down, 2 over again. 3 down, 2 over, 3 down, 2 over. There's my skeleton of my line. Now, this is equal to, it has that line, so I'm going to make this solid. That means anything on that line is included. And it says greater than. My y is greater than. That's a greater than sign. That means we're going to shade above. So we shade all that with that color. Okay. Now we're going to have to solve this one. We end up with x plus y less than or equal to 30. And let's solve this. We are going to subtract x, and that goes 0, and I end up with y is less than or equal to negative x plus 30. Let's graph this. There's my y-intercept is 30. 30 is that point right there. My slope on this one is 1 down, 1 to the right, because that slope is negative 1 over 1. So I go down 1, right 1. That's going to put us right in the middle here. But I know that is the same as going down 2 over 2. So I can just go corner of the dot, corner of the box, corner of the box, corner. And I'm just going to keep this pattern going down 1, right 1, or down 2, right 2, down 2, right 2, down 2, right 2, down 2, right 2. And if you notice, it'll end up back here at 30 since it's even there. It also has the line, so I can go ahead and connect these. This solid line again means that everything on that line is included. Okay. Now which way do I shade? It says y is less than. Less than. That means below. My solution for this type of situation is everywhere that they intersect or they cross. So everything in this area is covered both by my purple line and my orange line. Let's go ahead and plot points. 4, 4, yes or no? 4, 4 is that point. That's only in 1, so that does not work. Let's try 4, 8. Right 4 up 8. That's that point. That's in the yellow. That works. Let's try 2, 10. 2, 10. That is in the yellow. Barely, but it's in there. 6, 20. 6 right here. Follow that up to 20. Easily in my yellow. That works. 0, 0 is that point the origin. I don't know why we would choose that one. But here it is. If I look, it's not in either of them. Oh, sorry, it's only in the orange one. That does not work. Then I have the 12, 20. 12 up to 20. That's out of it. It is not in the yellow area. 12, 16. Let's check out 12, 16. That's in the shaded area. 16, 16. Not in them. That doesn't work. Let's try a point. I want to try my own points now. What if I asked for this point? 20, 10. It's on the solid line. Does that work? Yes, that works because it's on the line. Because it's solid. If that was a dashed line, it would not work. Let's move on to number 2. Let's move on to number 2. Jameson is vacationing in the mountains and wants to rent a bicycle. He found 2 rental companies. Bob's Bikes charges a non-refundable deposit of $10 and then $17 per hour. Per hour, that's my X. It's going to be changing. That's my fee right here, plus 10. Cammie's rental charges a bike fee of $15. That's my standard normal fee that doesn't change. and then $15 per hour of rental. That's my change. That's my slope. For each company, write an equation showing the total cost of rental, C, as a function of the number of hours the bikes was rented. My equation, my cost to rent, what's the first one? Bob's Bikes. And I'm going to put a little B down here just to say that, hey, we're doing Bob's Bikes. My cost to rent is my $7.50 an hour times my number of hours, which is actually H, so it said to do. And then I'm going to always add that $10. $10 rent, every hour I keep it, $7.50. Now I can do, what's the other one? Camis. So total cost of camis. And they're going to charge $5 per hour plus a fee of $15. Those are my two equations. Now, you can solve this many different ways. You can substitute them however you want to do it. I prefer, if possible, calculator. Either graph and look at the table or put it in as a matrix. I don't care which way. Either way works for me. I'm going to put it in the calculator because they're already in y equals form, slope-intercept form. I'm just going to plug it into y equals. First one we're doing, B, was it B's Bob's? Bob's Bikes, 7.5x plus 10, and then Camis, 5x plus 15, and then I'm going to go ahead and look at the table. What I'm looking for is where these two are the same. I want to know where they're the same. I don't, oh, I see it right there. There's both equal to 25 there. So that point is 225. 225 is the point. How many hours? My x is the hours, so that's going to take 2 hours for us to get there. So where they're equal. After 2 hours, they'll cost the same. So if you are only renting a bike for 2 hours, it doesn't matter which bike shop you choose to rent from. It will be the same cost. Now if he wants to rent for 5 hours, which will be cheaper? Oh, I'm just going to look at my table at 5 hours. Which one's cheaper? The second one. Which one was the second one we put in? The second one we put in was C, which is Camis Rentals. So that is Cami. Camis Rentals is the cheaper at 5 hours. Anything past 2 hours, Camis is cheaper. Anything less than 2 hours, Bob's is cheaper. That's what the system shows us. Let me just look at the graph of this real quick. Let's not. But it's going to show them intersecting like this. Anything before Bob's is cheaper. Anything after that intersection, Camis is cheaper. Okay, number 3. At the arcade, Sammy won 2 blue tickets, 1 yellow ticket, 3 red tickets for a total of 15,000 points. Jamie won 1 blue ticket, 2 yellow tickets, 2 red tickets for 1,225 points. Yvonne won 2 blue tickets, 3 yellow tickets, 1 red ticket for a total of 12,000 points. Write a system of equations to represent the situation. Let be blah blah blah. Create a matrix for your system. So we're going to write the system. So we're going to have, let's do Sammy, 2 blue plus 1 yellow plus 3 red is equal to 1500. Then we have Jamie, 1 blue plus 2 yellow plus 2 red equals 1225. And then Yvonne, 1 2 blue plus 3 yellow plus 1 red equals 1200. That's my system. That's all you have to do for the system. That is the system. Now, the next says the matrix. Create a matrix. Since I have these in the order, B, Y, R, or X, Y, Z in some cases, it is, my matrix is 2, 1, 2, 1, 2, 3, 3, 2, 1, 1, 5, 0, 0, 1, 2, 2, 5, 1, 2, 0, 0. That's my matrix. That's all it is. We good so far? Okay, number 4 and 5. I'm not going to go ahead and solve this because on 4 or 5 we're going to plug these in the calculator and get x, y, and z. If this asks us to solve it, this is how we do it right down here. Alright, 4. Let's go ahead and put that in the calculator. To put this in the calculator, we're going to use the matrix key. The matrix key is right here. It's in blue. So press the blue button in matrix. To do a matrix, we're going to need to use this tab, that tab, and that tab. There's 3 tabs on top of the matrix menu. We're going to start with edit, we're going to go to math, and then we're going to go to names. We're going to do it 3 times. We're going to use that matrix key 3 times each time put in the calculator. The first time we go all the way to edit, and we're going to plug into A. I highly suggest always using A. If you want to keep and remember which one A, B, and C are, it's fine. It's just a name. This is, which way is it? 3 by 4. So we're going to say 3 high by 4 across. And you can look at it here. You can see the 3 rows. Sorry, yeah, 3 rows. And we're going to plug these in. 1 enter, 2 enter, 3 enter, 9 enter. 0 enter, 1 enter, 0 enter, -1 enter. 0 enter, 0 enter, 1 enter, 3 enter. You need to make sure you press enter at the end. If you do not press enter at the end, it can cause problems. Once you press enter, you also need to quit. If you don't do those 2 things, you run into problems. Now we can go back to matrix. We did edit. Now we need to go to the math. We are going to go all the way down to RREF. We are going down to RREF. That is reduced row echelon form. Now we have reduced row echelon form. The matrix we just put in there, we need to put into RREF. So we go back the 3rd time to matrix. And we're going to put this 3 by 4 matrix we put in there. These are my solutions, X, Y, and Z. So I have X, Y, Z. Let's do number 5. I invite you at this point to see if you can get this done quicker than I can. So I'm going to go ahead and quit or clear this out. I'm going to go to matrix. I'm going to go all the way to edit. This is a 1, 2, 3 by 4, so I'm going to leave it 3 by 4. Go to my first spot and start plugging in. -2 enter, 1 enter, 3 enter, 20 enter, -3 enter, 2 enter, 1 enter, 21 enter, 3 enter, -2 enter, 3 enter, -9 enter. Again, I get to the end, I make sure I press enter. You can't do it too many times, won't cause a problem. And now I must quit. Go back to matrix for my 2nd time. Go over to the 2nd column or 2nd tab, and we're going to go down to RREF, reduced row echelon form. And now, once I have this on my screen, I need to go back to matrix for the 3rd time. And I'm going to press enter because I'm putting that A back in. Enter again. There are my solutions. -4, 3, 3. That is all there is to doing the systems. By the way, you could always do 2 by 2 systems that way too. For example, this system we did up here. We have, well, I'm not going to mess with that right now. We'll worry about that. Well, let's just go on and try to get this done with. Okay, number 10, 11, no, 10, all three parts of 10. Those are solving inequalities, not inequalities, absolute value. There's not a lot of room here, so let's see what we can get done without having to pull out a post-it note or something. First thing we want to do, I want to get my absolute value part by itself. I want to get my absolute value part by itself. I'm gonna work on a post-it, sorry. So we have 3x. So our first thing I want to do is subtract 2. I want to subtract 2 from both sides. What's that? I'm sorry, add 2. You're right. I want to add 2 to both sides. We end up with 3 absolute value of 4x minus 5 is equal to 21. Next thing, we want to divide both sides completely by 3. These 3's will cancel to 1 and leave us absolute value of 4x minus 5. 21 divided by 3 is 7. Now, when I have the absolute value, I separate this, plus or minus. We're going to split it. 4x minus 5 is equal to 7. 4x minus 5 is equal to negative 7. That's the quick way to do it. Okay. Remember, that's not the exact math way. It's technically this side that needs to be plus or minus. It needs to be this that's plus or minus. But, quick, short way, we just change the right side to plus or minus. Once I have them split into 2 equations, I can go ahead, solve them. They're the same steps. Add 5, add 5, add 5, add 5. 4x is equal to 12. 4x is equal to negative 2. My next step is to divide by 4, divide by 4, divide by 4, and I get x is equal to 3. X is equal to negative 1/2. Those are my 2 solutions. So if I'm writing the solution for this, it's going to be x is equal to 3 or negative 1/2. And we just simply plot those. If this was 0, this would be negative 1/2. And 1, 2, 3. That would be my other one. Just solid circles at those, solid dots at those points. The next one, it is slightly more complicated because it is an inequality. It is an inequality, so let's go ahead and work this inequality. Not much changes. So I have, first, I'm going to subtract 2 from both sides. I end up with absolute value of x is less than or equal to 3. When I have my absolute value done and solved for, my absolute value is by itself, I can now split it in 2. I get x is less than or equal to 3, and x is greater than or equal to negative 3. Not only did I change the sign, I changed the inequality sign as well. Positive, negative, greater than or less than changes as well. That's my solution. So when I'm graphing this solution, well, let's look at these. Let's plot these and graph those, and we'll talk about the ways to write this solution. So if I graph these, let's go ahead and say the center here is 0. There's no point there. And this is 1, 2, 3, 4, negative 1, negative 2, negative 3, negative 4. Equal to, so I'm at a solid dot at 3 and a solid dot at negative 3. So let's look at the 3 first. Positive 3 says my x is less than. That's a less than. That means I'm shading that way. So this is going to go that way. And my negative 3 is greater than. My x is greater than negative 3. It means I'm shading this way. So they're shading in the same directions. They're pointing in the same direction. That means anything in here on these points or between them are parts of my solution. Because they're combined into one, I can write that two ways. I can write it as I see up here. X is less than 3 or x is greater than or equal to negative 3. But I could also represent that as negative 3 is less than or equal to x less than or equal to 3. That's another option. And then there's another option that I like, set notation, negative 3 to positive 3 inclusive. Any of those three will work. You need to recognize all three of those. If it's multiple choice, that's whenever you need to tell the difference of them. To me, this is easy to write. I like this one the best because it's the simplest. Yes, sir? Because it's always going to be the smallest to the largest, and these arrows are always going to point to the left. Always smallest to largest, always pointing to the left. Last one, straightforward inequality, not much to this one. The inequality is already solved for or isolated, so we're going to have x minus 3 is equal to 4, x minus 3 is equal to negative 4. Go ahead and split that. X is equal to, we add 3 to both sides, 7. X is equal to negative 7. So my solution is x is equal to plus or minus 7. If they're the same number, just positive, negative, we can write that as plus or minus. Plus or minus means there are two. Graph it, wherever 7 equal to, wherever they saw it, negative 7 and 7. Whatever the scale is. Okay, certain forms of quadratic functions tell us different information about the graph. What can we see with these? Okay, the first one. This is factored form. That is factored form. First factor, second factor. It's positive. Anything positive opens upwards. My zeros are real easy to tell. My first zero is 1. My other one is negative 5. It's just the opposite of what's in there. You technically set these equal to 0. For example, if I set this x plus 5 equal to 0 and solve that, x is equal to negative 5. That's how I get negative 5. It's a little bit more complicated. There's a number, a coefficient in front of the x. Then it ends up being a fraction, and that being the denominator. So if that was a 2x plus 5, for example, that would have been negative 5 halves. B, we now have something in standard form. Standard form, it's negative in front. That means it opens down. My y-intercept, that's the last number in standard form. My y-intercept is 5, or 0, 5 if you want the whole point. So this would be 0, 5. And if I want my zeros here, 1, 0, and negative 5, 0, if I wanted the points. And last one, this is vertex form. A value leading the whole thing is positive. It's actually 1. You don't see it. So it opens up. And then my vertex, we have h, which is this, but we use the opposite mirror. Anything inside these parentheses when we're writing it like this, negative 2, and my k is right here. Nope, not 2. 6. And then it asks if it's a max or min. Well, if it opens upwards, it can only have a minimum. Domain of h. My domain of quadratics is always all real numbers. You can write it as all real numbers. Just say all real numbers. You can do the funny R thing, or you can go, negative infinity to positive infinity, not inclusive. My range, opening up, my smallest point is going to be k, so it's going to go from k, which is 6, that's the lowest point, and that's going to be the very ending value here. And then since it's going up, it's going to go all the way to positive infinity, and infinity is never inclusive. Alright, let's do some matching. Alright, we have 2 that open up and 1 that opens down. The only one that opened down was b. This would be function g of x. Oh, can't see that. Only one that opens down is g of x. Okay, we have 2 that open up. What's the difference? Well, this has x-intercepts at 1 and 5. Well, this one has no x-intercepts. They are imaginary roots. So this has to be f of x. And this has to be the one left over, which is h of x. And that makes sense because it looks like that's about 6 up. And my vertex is negative 2, which means it's pushed off the left. Negative 2, 6. That looks right. Identify the following for the graph. Which direction does it open? Positive in front, opens up. Axis of symmetry. Axis of symmetry, x equals negative b over 2a. My negative b and my 2 times my a, let's see what we're going to plug in. B is 10, a is 1, so we end up with negative 10 over 2, which is negative 5. Axis of symmetry is always an equation, x equals negative 5. Vertex. If it was in vertex form, it would be easy. Standard form, I'm all for using the calculator if possible. Hopefully we can use the calculator. Let's go ahead and graph it. Clear anything out of it. X squared plus 10x plus 23. If I look at the table, I want to find points that repeat. That looks like it is increasing more and more. Doesn't look like that's the direction I want to go. Oh, there we go. Do you see the repeatingness of this? Do you see how we have a negative 1, and here we have a 2 and a 2? And how right in the middle is one loner number. That's my vertex. My vertex is negative 5, negative 2. And the very last one we have, a penny is dropped, a function that represents its height in feet of the penny t after t seconds. Here's the equation. Sketch the graph. Let's go ahead and sketch it real quick. It's going to start, since it's in standard form technically, well, yeah. That's my y-intercept, so it's going to start at 76. And negative means it's going to drop down like that. That's as good a graph as I really care about having. Reasonable domain for this situation. So let's put this in the calculator and try to figure out our domain. If I clear this out, negative 16x squared plus 76. And if I look at my table, Let me go to the positive. We can't have negative numbers in most real situations. Let's see if we can find out where this hits the ground. Let me change my table set and make this go by 0.1. See, I'm going to make this go, every x is going to increase by 0.1. And, good table. Alright, let's see where it hits 0. 1 second, 2 seconds, 3 seconds. Oh, passed it. Oh, somewhere between 1 and 2.1 seconds and 2.2 seconds, it's going to hit the ground. So it's going to travel about, let's just call it 2.15 seconds. My domain for this situation is 0 to about 2.15. What is a reasonable range? Well, my range is smallest, which is 0, to my tallest, which is 76. That's the top of it. When will it drop less than 50 feet? Well, I can just keep going up my graph, find where it hits 50 feet. So basically anything, let's go about halfway in between, anything after 1.25 or after. So 1.25 to, it'll technically go on forever, but let's just say it will go on to this 2.15, which is where it would end. So but anything after 1.25, to see that's where it will be less than 50, wherever that is. That's where it would start being less than 50.